Bismillahirrahmanirrahim. My name is Junaid Abbasi and my group members are Muhammad Ahad and Musaddiq Khan. Our final year project is 3D printer and our supervisor is Engineer Sayyid Muhammad Rihan Ali. So what is 3D printing? 3D printing or additive manufacturing is a process of making three-dimensional solid objects from a digital file. The creation of 3D printed object is achieved using additive process. In additive process, an object is created by laying down successive layers of material until the object is created. 3D printing is the opposite of subtractive manufacturing, which is cutting out a piece of metal or plastic through a milling machine. 3D printing enables you to produce complex shapes using less material than traditional manufacturing methods. So workflow of 3D printing. In 3D printing, first of all we design the 3D object in CAD software like AutoCAD and SolidWorks. These software generate file with STL extension. Then this STL file goes to slicing software like Cura and Slice3R. Then slicing software slice this 3D model into layers and generate G code. Then this G code sent to the printer line by line, and printer follow these commands and create 3D printed object. Our problem statement is to build affordable, precise and cost-effective 3D printer. Our solution methodology is making a FDM 3D printer using Cartesian design. Our maximum print size is 200 by 200 by 300 mm, and we use acrylic sheet and metal rod instead of aluminum rails and frame to reduce our build cost. So FDM works using a plastic filament which is unwound from a spool and is supplied to an extrusion nozzle which can turn the flow on and off. The nozzle is heated to melt the material and can be moved by numerically controlled mechanism. The object is produced by extruding a melted material to form layers as the material hardens immediately after extrusion from the nozzle. Similarly, other layers are laid down until the final object is formed. Cartesian design. In Cartesian design, bed of the printer moves in y-axis, means forward and backward, and hot end of the printer moves in two directions, means x-axis left and right and z-axis up and down. Software that we used in our project: AutoCAD to design 3D objects, Arduino IDE, Slice3R and Cura, slicing software, printer-faced host software that communicate with printer, and CorelDRAW to design our acrylic sheet. Main controller is Arduino Mega and main motherboard is Ramp 1.4 Shield. Ramp 1.4 Shield provide interface between all electronics component of the printer and the controller. Use RipRap discount-full graphic smart controller. This is basically 128 by 64 dot matrix LCD display with an SD card reader support. It has also a rotary encoder. This is a simple solution to interact with 3D printer without a computer by using just SD card. We just upload G code in SD card and feed into the printer. Marlin firmware for our 3D printer. Marlin firmware is an open source firmware. Its programming language is C++. It has PID control system to control the temperature of hot and heated bed. It has also a safety feature and thermal protection. Raw design of our acrylic sheet that we are using in our 3D printer. Export we use 6 mm acrylic sheet, and for front frame we use 8 mm acrylic sheet, and for base of bed we also use 8 mm acrylic sheet. We use 3 types of rod in our project: thread rod, lead screw and linear rod. Thread rod is used for bed frame. Linear rod and lead screw used for the movement. Drive system, we use combination of pulley wheel and timing belt to control X and Y axis, and for Z axis we use the combination of flexible shaft coupler and lead screw to derive Z axis. Diagram of our project: we use total 5 stepper motors, one for each X axis, Y axis and extruder. We use two stepper motor for z-axis. We also use LCD controller, and we have two heating elements. One is heated bed and other is hot end. We use two thermistor, one for heated bed and one for hot end. We use three mechanical and limit switches. All these components are connected to Arduino Mega through RAM 1.4 shield. Fully functional project, and on the right side 3D printed cube 20 by 20 by 20 mm. Here is our project in fully working condition. We use 0.4 mm nozzle for our project. Quality of print defined in terms of layer height, also called resolution. On the left side 3D printed object with layer height 0.4 mm, and it takes about 28 minutes. On the right side 3D printed object with layer height 0.2 mm, and it takes about 54 minutes. The object on the right have good and fine quality due to smaller layer height. Object that our printer prints. In future we can add multiple extruder in our project for multicolor objects. We can add auto bed leveling system. We can use direct PLA feeding system instead of Borden system. We can customize the dimension of printer to print bigger objects. So thanks for watching.